Since we started working with the ESP32 and DHT11, we have been playing with getting it up and running in the background and logging data to the PC when the PC is on. This has been quite challenging, but we now have something to show you.
So the first step of this was to have a consistent while loop running on the ESP32 to record the data, which we'll show you here.
Our network and password is saved up as variables up above here. Obviously we've had to take them off the screen, and then we just do all our imports, and we've built this function to connect to Wi-Fi. This creates a network object, and if it's not connected, it's printing this quick message. This is just for our benefit, and then it sets this sort of function or sets this parameter to active, and active is just there basically attempting connection. It will just wait until it's got a connection, and once it is connected, it will continue on from this function into our sort of next step. Now our actual code is basically these 3 lines here plus this line, or these 2 lines at the bottom, and then these are our function declarations, and at some point we will wrap these up into separate files or make this all a bit sort of tidier so there's very limited code on one screen. But once we've connected to the Wi-Fi, we basically find our socket, and then we move into our measure sensor function from before. And if you've missed that one, I'm not going to talk about it here, but it's in the first video for this project series, so have a look at that. The only change we've made to that is this client.send, which is now included in the measure sensor function. So every time the measure sensor function is called, it takes data from the sensor, saves it to a variable, and then sends it over the socket. And that's encoded here for binary, and then it reaches the other end and then gets decoded again. And that's called here after our timer has progressed for 5 seconds. And obviously when we come around to it, we can change the time between data points just by changing this period here.
And once the ESP was consistently logging data, we could look at sending that data over the built-in Wi-Fi module back to the desktop when a script is running on the desktop, kind of like a server script. And this was surprisingly challenging because if the ESP disconnects from the Wi-Fi for any reason, it doesn't automatically reconnect, and we had to write in a function to check that connection periodically and then upload backlogged data from the internal storage on the board.
The server side was listening to a specific port on the home network, where it was expecting to receive data from the ESP32, which looks a little bit like this.
So I'm going to talk through some of the server side, and then we'll go back and look at the MicroPython and how it connects to the server side here. So we start by importing the socket, and this is just a common Python library for this sort of work. Client equals socket.socket is creating a socket object. The parameters are for initializing this socket, and we're not 100% sure on what these parameters exactly do, but they are definitely necessary. And then we're just binding that to our local IP on port 8080. Client.listen is listening for up to 5 connections. That's what the variable is, but we're obviously only expecting the 1. And then we enter our first while loop. Our first while loop is just waiting for a confirmed connection before we move on to our second while loop, which is listening on that connection to receive data. When it receives the data, it's saving it into the variable data. Connection.receive 4096 is listening for binary data and then being decoded to UTF-8 format. And then we have this little break that's basically saying when there is no data, just don't do anything. And as soon as it receives data, it then moves past the break and prints that data to the terminal. So now we've got both our scripts over here. We can run our server-side script, that's just running, and then we can run our MicroPython script, and you can see it's waiting, network connection, and then has recorded our first data point, and you can see these popping up every 5 seconds over here. It's recorded on the device, sends it to the computer, records it to the computer.
The data received from the ESP32 was then saved to a CSV file for data visualization later down the line. Up until this point, the ESP32 was in the room with us, so we could troubleshoot by printing issues to the terminal and play with the code and iterate very quickly. But then once we were comfortable with it, we stuck the thing in the loft to read data over the socket, and it worked fine. So we closed the hatch and entered integration hell.
Yeah, and this is really where this project sort of threw us for 6. Because the next time we ran the script on the PC, there was no data, the ESP was disconnected, and this was where we realised we needed the auto connect function. So we wrote that in, returned the ESP to the loft, and had the same issues. And after a lot of troubleshooting and banging our heads against the wall, we realised that basically when we were troubleshooting this, I was stood on the ladder of the loft with the ESP in the loft, and we were shouting back and forth, getting the data back. And it was only once we confirmed that it was working, I came off the ladder and closed the loft hatch, that the ESP lost connection to the Wi-Fi. And that took us, probably 6 to 8 hours of messing around before we actually clocked on that when you close the hatch, you obviously interrupt that connection somehow. But at this point, we got a bit stuck. We can't leave the hatch open because it's freezing up there, and we can't record data when it's closed. However, this also kind of answered what we set out to do in the first place, because the loft was clearly freezing cold. The data that we were getting with the hatch open was showing 10 degrees Celsius or lower, which is pretty chilly when you're trying to type things out.
But having started the project and having some interesting challenges and potential with the home automation server side, we decided to continue it in other ways and let it get way out of control.
So we've answered our original question about whether or not the loft is a usable workshop, but more importantly, we've found a project that we have let spiral out of control and now intend to continue with. So we have a few plans to integrate with some actuation, along with wanting to log different types of data, and might use this sort of system to create maybe like an airing cupboard type space for drying laundry, or something like a humidity and temperature monitored greenhouse. If you have any questions about the project or suggestions on what else we can do with it, please let us know, and we'll do our best to answer any questions or troubleshoot any issues if you've had any and you're kind of following along. Otherwise, we'll come back in a couple of weeks with some more information on what we've done with it, and we'll see you later.
Yeah, bye for now.